So hello everyone, in this task we are supposed to implement a circuit. In this we have three modes. First mode deals with the turning on all the LEDs and using the frequency of 0.5 Hertz. The second mode is dealing with counting. So what happens is starting from 0 moving up to 6 bits, which would be around, we could count from 0 decimals to 63. And the third mode is counting down, which means we are starting from 63 and moving up to the 0 decimal. So let's look into that. Firstly, let's look into the header file. So header file is just basically giving the name to the particular file, defining it, and then we have the libraries. For the CMSIS we have to use the SAMD21 library, then dealing with the enums, because to make it much more simpler, input and output mode, assigning them a particular number, which would be 0 and 1. That's what binary is all about. Then other enums stating the low state, high state, and then the system stopped and running. Same happens, blinking all at once, and then the count up, so defining different modes 1, 2 and 3. One would be blinking all the LEDs, second would be the counting up, and third would be count down. So let's again the similar thing happens is we are associating this entire code with the 6 LEDs, and then the debounce of 200 milliseconds. Debounce in just the case because we want there not to be any false values, so taking it a certain sort of delay helps to regulate it properly. Then the in this code we have two buttons. One would be moving from start, then stop and reset, and the second button would be dealing from changing different modes. So one would be the at port A06 would be dealing with the button 1, and port 05 would be dealing with the button 2. Then the other thing is like associating all those LEDs, and then the structure would be particular instance. All those things are defined over here because the header file deals with defining those and then implementing those in the .cpp file. So let's look into the .cpp file. Same, these are the particular pin numbers that would be using for this code, and defining them like global variables would be like when does the system stop, what mode is we currently at. Is it the blink all LED mode? So at the very beginning would be the blink all the LEDs. Then the button pressed at the very beginning would be false for both the buttons. Then the last button times at the very beginning would be stating from 0. And same goes for the timer tick counter, binary counter, and the LED blink state. Then we have the polling time, and which is 10 milliseconds, so it keeps on checking whether a button was pressed or not. And then the pattern time for it. And then again what kind of port we are selecting. Default would be 0, which means the port A. And GPIO functions like what particular pins we are dealing with, and setting those, which means we are setting those to be output direction set, which means those are output instead of the input, because we are dealing with the LEDs and those are particularly defined to giving the output. And again, or else we are configuring them to clear, because we don't want them to be high, we want them to be low. And the outside again. And let's moving on to the next part, which is writing onto those GPIO pins. Again, masking the particular pins, like which pins are selected, only masking them to be at the state 1. And then again, which means like checking which state is actually high or low. Reading all those pins. Timer function, so here we have the timer function defined, and timer counter 4 was defined in here because we don't need to deal with the PWM. So making it much more simpler, you can either select 3, 4 or 5, it's up to you. And initializing the timer, and the very beginning that we have to check is like we have to enable the peripheral, And moving on to that, we have to check the synchronization. And after synchronization, we have to check like the particular interrupt or not. And then we have the timers. We are starting the timer and all those things, like timers is running and stating it true, and if the timer is stopped, stating it false. Then particular interrupt function, so global interrupt. Then we have an external interrupt setup, which is like whether the push button was pressed, whether it was the push button connected at the port 5 or at 6, and setting the binary LED. So it actually helps to count like, okay, we are counting the number 1 or 2, all those things are done here. Then handling the button 1, which is like start, stop, reset. And the handling the button 2, which is mode 1, mode 2 or mode 3. And checking the current mode and setting like what is the current mode, what do we need to set the binary yet, and then the external interrupt. And this is the main loop, which actually writes on the serial monitor, so we know which current mode we are working with. And .ini file just has the setup. So let's look into the circuit now. So let's look into the circuit. We have 6 LEDs, 2 push button. This is to the change the actual like start, stop and reset, and the other is to change the mode. Let's just reset our Arduino. All the LEDs would be tested once, and let's just start with the mode 1. So every LEDs will be blinking at the frequency of 0.5 Hz. Let's just stop it, and let's just change the mode and start it. And reset is done, so let's now start it. And for the count up, this one's will blink first, and then this one will blink to count 2, and 3 would be counted 1 and 3. Let's see if that happens. One, 2, 1 and 3. Again 4. So this is working fine. Let's just change a mode. So reset it. Again changing it to 3. Now all these LEDs should glow, because 63 means all this 6 bits should be 1. So let's just start it. Okay, we are currently at mode 3, and let's start it now. All these are, so this means it's working pretty fine. So that's how you do it. Thanks for watching the video.